All right, hey friends, we're just going to go through the proofs on the use of corresponding parts of congruent triangles. In other words, what we were doing in class was just defining overlapping triangles. So these notes we did in class, and they'll be posted on the module for today, but due to the Wi-Fi connections, we weren't able to really do anything after that. There was only 3 examples, so I do want to go through those 3 examples with you. So you can read the directions. They were supposed to name overlapping congruent triangles, blah, blah, blah. We're really just going to be looking at these proof statements. So whenever we have a proof statement, we want to see what we're trying to prove. So triangle LNK should be congruent to MKN. Now, the first part when we're dealing with overlapping triangles is identifying them, right? So LNK is here. Now, I have this cool ability to obviously take that triangle and move it, and we're going to see it overlaps with this other one, MKN. So when we're working with overlapping triangles, one of the biggest things we'd recommend to do is to redraw them. Now, if you can't slide them, I'll demonstrate that in the next example, but we just want to visualize them being separate. So KLN would look like that, and then this other KNM would look like this. So first of all, we want to separate the overlapping triangles. So then, just like we would with a normal proof, we're going to go in and label the givens. Now, when we have overlapping triangles, though, what we'd want to do is I want to label them on the main diagram, but it also will be helpful to label them on the separated diagram. It depends what we need and where we should look, so I always recommend labeling them in both places. So for instance, when it says LNK is congruent to MKN. So LNK is in this triangle, and MKN is in this triangle. So in the individualized triangles, I want to state that LNK is congruent to MKN. But I also want to do it in the combined image because I might need some information there. So LNK is congruent to MKN. So I've marked those 2 angles congruent. Now the next thing that we know that's given to us is angle MKL is congruent to LNM. Now, MKL is not in this triangle. LNM is not in that triangle. MKL is not here, nor is LNM. So I can't label them in that triangle, but I will label them on the big image because they will exist there. So MKL is right there, and then LNM is here. Now, we've labeled the givens. Now, with overlapping triangles, one of our best tools will be noticing that they share a side length, right? So if I can see it here in black when they overlap, right? Or I can see it in this image here. They both have side length KN. So the side that they share should be congruent. So we'll make the statement that in both of these triangles, we see side KN. And we know that side KN is, of course, congruent to itself by the reflexive property. Now, what we're noticed today is really the new skill is just separating the triangles. All the other facts that we prove on the methods that we have are going to be the same from before. So I'll mark that side length the same. Now, what I recommend doing is take an inventory, right? We currently have an angle and a side in each of the triangles. So the rule that I'm using is either going to be side angle side or angle side angle, because those are the only ones with an A and the S. Or again, I could be thinking about angle side. Now, when I start going through those, what would I need to do? Well, if I was going to use side angle side, the angle needs to be in between the sides. So I would need to know something about NL and KM. There's just nothing I can do with NL and KM. Although they look the same, I have no way to prove that they're the same, so I can't use that. Now this next one, angle side angle, if I used that, this angle and this side, so I would need something about angle NKL, and then in this triangle, it would be KMN. So if I look right now for those angles, NKL, so here's angle NKL, which I'm doing in brown. And then the other angle I would need, right, in this triangle, that's NKL. So angle side, I would need KNM to complete my angle side angle. So if I find that in the image, M and K, we notice that the vertices that they're highlighting is this one and this one. And of course, they're going to be the same, right? If this little part is the same as that part, and this part is the same as that part, and we add them to make an angle, both of those are going to be the same. So we found that we could prove those two angles congruent, right? So we said angle, and I'll mark it with three marks here. NKL is congruent to angle KNM. And that's our angle addition property. If we have two congruent angles and another set of two congruent angles and we add them together, of course their answers are going to be the same. So this is our addition property, or like our angle addition property. So then we've done it. We have an angle and we have a side and we have another angle. So we've proved that triangle LNK is congruent to triangle MKN, and we've done that by using the angle side angle rule. Example letter B here, what we're tasked to do is identify that triangle TWV. So TWV, make that a little smaller. And then the other triangle that they're trying to identify is UWX. So we can see that there are some overlapping triangles here. Now, if you don't have the ability like I do on the iPad to like highlight and slide them, what I would do is just trying to draw like an aerial view of them. So like if this is T kind of cuts across, goes down a little bit, and then there's that little arc going down like that. And then that might be a little too small, so maybe I'll do it a little bit bigger, just have some more room. So T kind of cuts down to the left, and then there's that diagonal down there. So then I label it T, V, W. Now with the other one, U's kind of in the upper right-hand corner, and it dashes down, and there's this little diagonal going lower to the right, and we go back up to where we started. So U, X, W. Now, when we see overlapping triangles, I also recommend putting in other dots on the line segments. So for instance, this side was TW. So on this side, TW, I still want to know X was somewhere there. So I would also recommend just labeling the dots. Just like on side WU in this triangle, there's a point V that's a little bit closer to U. I would recommend putting those points down as well when you redraw the triangles. So we've looked at what we're trying to prove, so we can identify the overlapping triangles. Once we redraw them, we're going to go label the givens. So the first given is TX is congruent to UV. So we want to do it in both places. On the combined image, so TX is congruent to UV, but also on the separated image, TX is congruent to UV. We'll move on to the next one. It says XW is congruent to VW. So I want to do that in both images. So here's XW, and here's VW. If I look in this image, here's XW, and here's VW. So that's all we have. So what we can start to look at here, that's what we have for the givens. Now, once we're done with the givens, when it comes to overlapping triangles, just like we did with this one, they usually share a side or an angle. Like that was kind of our definition of overlapping triangles. So just like we had here, they shared a side and we used the reflexive property. When we have overlapping triangles, that reflexive property is going to be important. And we should notice that they both have angle W in them, right? This is angle W here, which I'll label in like an orange color. And this is angle W there, right? Angle TWU. TW, I could call that TWV or TWU. So again, they share that angle. So with overlapping triangles, we can just say that angle W is congruent to itself because that's descriptive enough with just that one letter. And the reason we knew that is because of the reflexive property. And again, when you're using overlapping triangles, you'll want to use the reflexive property. So what I'm starting to take inventory of then, since these aren't a right triangle, I have to be using one of the rules like this. Which one of these rules do I want to be using? So I'm going to start marking what I have. We have a congruent side in each of them. We have a congruent angle in each of them. So I'm either going to be thinking about angle, side, angle, or I'm thinking about side, angle, side. So if I'm thinking about angle, side, angle, I would need this angle, which is angle TVW. And then I would also need this angle, which is WUX. So if we locate TVW, which is right there, and then we locate XUW, there is no relationship that I have between those two angles. There's no parallel lines. There's no angles that I could add up or anything like that. So I'm going to be deterred from trying to use that other angle. So maybe I'm supposed to use side angle. So if I had this side, this angle, I would need the other side. So angle, side. Now when I look at this image, the side that I would need to show congruent isn't marked congruent in this image, right? We see WU, that is not congruent to TW yet. This little part of TW is congruent to that little part of UW, which is why we might not look at this individualized picture, we might look at this picture. What we should see here is the side length, TW, which is the one I'm trying to prove here, right? We said XW was congruent to VW. So in this image, I can see that, and I could also label that XW, right? There's XW there, was congruent to VW there. Put 2 tick marks there. Actually, it's got to be 3. But what we notice then is if this little part and this little part are the same, and this little part and that little part are the same, then the entire side lengths would be the same. So option number 3, or step number 3, is we can show that side TW is congruent to side WU or UW. And the same thing, right? If we have 2 congruent pairs, then the adds of those pairs are going to be the same. So that's by our segment addition. So then we can prove the triangle's congruent. Triangle TWV must be congruent to triangle UWX. And the rule that we used in our image was side angle side. Our last example for today. So we're trying to prove that triangle ADC, so here's ADC, is congruent to triangle BCD. So triangle B, let me use a different color. Triangle BCD. So we identified the overlapping triangles, so we should redraw them. So angle A kind of comes down, goes flat across, and cuts back to the upper left. So that'd be D and C. The blue triangle has kind of B in this upper right-hand corner. It goes diagonal down to the left, stays flat, and then cuts back down. That's D and C. So we should label the givens. Now, just like we learned in the last example, side AC and side DB, that point X was on both of them, so I would recommend putting that on your other image. And notice how X seems a little bit closer to A and seems a little bit closer to B. I just don't want to assume that's a midpoint. It just doesn't tell me that it is. So now we should label our givens. So AD, here's AD, is congruent to BC. So I want to label that in both of my images. AD is congruent to BC. The next piece of given information is AX is congruent to BX. So here's AX, and that's congruent to BX. In the other image, here's AX, and here's BX. And then the last thing that's given is XC is congruent to XD. So in this image, here's XC, and here's XD. In the separated image, XC and XD. So those are just labeling the givens. But I also consider when I'm working with givens, if we have overlapping triangles, we should always know there's a reflexive property in there. What side length is in both of them? Or in other words, I can see here DC and DC are in both of them. Or what side do they overlap in that image? You always want to look for the overlapping parts because we know they'll be congruent. So we know DC is congruent to DC because it's the same in both of those triangles. So that's our reflexive property. And then I'm going to label that, since I haven't done that yet. I have to use 4 tick marks. All right. So after doing that, I only have one little statement that I need to show. I have shown that DC, this side, has 4 tick marks with that side. I have a side with 1 tick mark. Now, technically, this side and this side have not been marked congruent to each other. I've only shown that this part of the segment is congruent to that part of the segment, and this part of the segment is equal to that part of the segment. Nowhere have I said yet that the entire segments were the same, but of course they're gonna be, right? If I have 1 and 2 in both, like 2 pairs, like if this was 1 and this was 1, and that was 2 and that was 2, if I add them, I'm gonna get the same answer, right? That's our segment addition property. So I know that AC is congruent to BD, right? Because the 2 tick marks plus 3 tick marks should be the same as 2 tick marks plus 3 tick marks. And that is our segment addition property. So then I'm able to show that all the sides of that triangle are congruent. So we can make our statement that triangle ADC is congruent to triangle BCD because we've shown that all 3 sides are congruent.